Hello and welcome to yet another video. And today we have something very special that I've never had before. We have a big job lot of mainboards. These are 1, 2, 3, 4, 5, 6, 7, 8. I think it's 9 mainboards in total that we have throughout different generations. Like we have Z170, we have H110, H410, H510, I think. So there's a lot of different boards with different faults. And yeah, I've paid very little for these because these are job lots. They come without the bracket, so the IO shield, and yeah, without the packaging, without nothing. Often some even come without the heat sinks. And I would say we just start by using or getting out one of these and just looking at them. I specifically looked at that these don't have any damage in the sockets if they're Intel boards, because I do not want to repair that. Some of these have previous repair attempts, but I'm not too sure about which ones had what. So we're going into basically each of these boards blind, and we're going to be having a look at them, what they have. And the first one here is a Z170 Pro Gaming. Is this MSI? No, this is Asus. Okay, yeah. So Asus. So, the big problem I always see with having Intel boards is that these very often have dead PCHs, and we might have that this time also. And what I can already see is that this is missing the heatsinks. So the heatsinks from the VRM are completely missing, and also the cover for the USB 3.0 here is missing. So there's only the pins there, but that should still be working. So let's get our power supply into here and see what passive power consumption we have on this board. So let's look at the passive power consumption. And we have 140. But that might be not a dead PCH, because we actually have a lot of LEDs on here. So that might be the reason why we have that high of a power consumption. Because normally on Intel boards, as soon as I see this power consumption, I'm instantly concerned about the PCH. But with the LEDs that we have at the front here and on the back of this side, let's get a CPU into here and see what this does. I will first have to look up what this CPU this supports, but I think this is 6th and 7th gen Intel. So let's have a look. We have a CPU in here, and it reacts to the power button. We do have postcodes. We have 1.3 amps. We have 80 as a postcode, and it restarted. And let's see. It's running up to DRAM LED. And now it's VGA. Okay, and now it's on boot. Okay, this seems to just be booting up. Okay, yeah, I expected this also to happen in this job lot, that sometimes it may just work. So let's get a heatsink on here. Let's get a video output onto here and check this board. We won't be checking it in detail, because I will be checking those when I actually have most of them fixed, and then I would completely check them, like run stress tests and all of that. But let's first see if we can get a picture out of here, because all of that, what this board might have then, is missing heat sinks. So let's see. We have 1.2 amps, it's a DRAM LED, and now it's going to VGA. And let's see, and we have a pause screen. Okay, let's quickly check if it takes all DIMM slots of RAM. So let's just check that it sees all 4 DIMMs of RAM. This is still the stock image from before. Let's see, we have DRAM LED. Let's see now if we get past the DRAM training. The current is jumping a little bit, so I would think we're not stuck, but we're training. But let's see. Okay, so we're not booting with 4 DIMMs of RAM in here. So that might be because of dirty slots or something like that. Let's see how many we can get working and in which slots. So I will be removing one by one, and I will see with how much RAM we can actually boot. And yeah, so removed one stick and still no boot. So we're going to turn off again. So with 2 sticks of RAM now. Okay, we're not booting with 2 sticks. Okay, let's just move this one then to like this slot here and see if we can boot with these 2. So currently we seem to only be able to post with the single stick of RAM. Let's try that again. Yeah, now we have higher power consumption. Now we have restarting. So this slot seems to work. Let's see if we can get more than this slot to work. So this slot is now posting. We should get an updated video output. Yeah, there it is. So this is the updated video output. So let's see. Yeah, this is the BIOS. Okay, let's see now. With starting with which one it won't work. So let's put this one in and let's see if it works. Okay, so these 2 work. I now have VGA out of these 2. So let's turn it off again. Let's use another stick. Put it in this slot here. Okay, and in this slot we currently don't seem to get boot. So let's remove this one also and put it in this slot and see if it's only that slot or is it these both. Okay, so it seems like these 2 left slots are not working. So we're not posting in those. That might be due to damaged traces somewhere. So let's have a look at the data line tester that we have for DDR and see if we have missing lanes in these 2. So having now taken a look at the backside, I can already see some spots that have physical damage, like trace damage, and that might be why we don't have certain RAM sticks recognized. So let me show you under the microscope. So we can see around one of the mounting posts, we have a lot of physical damage here. But I think none of these traces are actually ripped through. Except maybe these top ones. So these are fine. This is fine. Let's see for these ones. So it seems like this is not damaged. But let's take my Dremel. Because the Dremel just works way faster than using the scalpel knife. So let's get our big guns out here. So what we do is after we've scraped away the masking, we're going to take IPA, just going to clean it up. And we can see that pretty sure that this top one is fine. And pretty sure the lower one is fine as well. Like, these are big traces. Yep, this is all fine. None of these are damaged. These look awful, but none of these are damaged. So none of these is our problem. So what I've also saw is whatever this is. This looks like a piece of tape just. But let's remove that as well. Okay. Yeah, this is just tape. And I have seen another place of physical damage, which is this one. This looks a little bit more damaged, but I don't think that there's anything broken here. Because as you can see, this one, this big one, there's nothing here. There's no big break. Like, you see this one line here, but this is a big trace, and you see the copper still in there, just like here. So all of these are still fine, I'm pretty sure. But let's see. These small ones we might need to check. And now the masking is removed. And if we look at it now, we can clearly see there's no break in these. These are all continuous. And here at the top, there's one big trace going here. So especially this corner is kind of damaged, but the trace is still continuous. So that is also not our problem here. So I can see one more around another mounting hole, which is right here. And this one is even worse. But yet again, I'm pretty sure none of these are damaged at the point where they need repair. Like, if you look at these lower ones, these are really dented in, but the copper is still continuous. There's no break in them. So yeah, all of these points look physical damaged, but they are fine indeed. Like, it's not pretty, but it does work. So let's have a look at the socket together. But these look very fine, I got to be honest. Yeah. Socket looks really good. So no damage there. What we might want to check now is closer from here, because running on the upper side here are most of the traces that go to the close slots or dim slots that we have problems with. So let's have a look at these, if we can see any damage. But they do look clean. What I want to do is I want to remove this cover here, just to make sure that under that everything is good as well, that we have no hidden surprises there. And now having the socket removed, it still looks fine. Let's see what has happened here. This is the VRM controller, but the VRM is working. I really don't know. Just probably just some dirt at the corner there. See here. Like, it doesn't look nice, but there's nothing properly damaged here so far. So I really don't see a reason why these slots are not working. Looking at these slots, and yeah, can't see any problems with that. Very, very interesting. So what I will try now is just clean the dim slots out as much as I can, and we will see if we can get boot out of that. So what I always do is I take a dim, I take loads of IPA, and I just drench this one in IPA. So I put loads and loads of IPA onto the gold contacts. And you have to be quick because the IPA evaporates quite quickly. And then what I do is just run this in and out of the socket or the dim slot. So try this a couple of times. Now with having cleaned out this slot, let's see if that already made a change for us, because we couldn't see any physical damage. So it still seems to be stuck on DRAM LED, which is very annoying. So cleaning out that slot didn't work for us. So let's try with the other slot. So after cleaning out the other slot, it also didn't make a difference. So because I didn't see any physical damage, or at least any that is related to the RAM, and cleaning the slots also didn't work, I will be trying to cross these, like change out the DIMMs and see if the DIMMs also work in here, but they should. And if that doesn't work, so what I will be trying is to put a different BIOS onto here, because we do, as you saw, we are able to boot. So I will be just using the internal BIOS flasher for that, to make it way easier on myself to flash it. And yeah, that will be mostly my last resort in order to try to fix this board. So I've currently got a cooler onto here. I like to put a cooler on when I'm flashing the BIOS, just so the CPU doesn't overheat and we get crashes or something like that. And I've also have a USB stick on the top here with a BIOS file. And let's see if flashing the BIOS will help our problem. And currently in the process of flashing the BIOS. So flashing the BIOS sadly did not make any difference. And now I've taken my DDR tester. And let's put the DDR tester into the functioning slots. And if we look now, you can see very clearly that basically all of them are lit up, except the ones that are marked in black. Those are for ECC RAM as far as I know. And if we go into the slots that are not working, for example this second one, which results in that all of these are also lit up, which is a problem for us. So all of the data lines are intact for this RAM or these RAM slots. So what I have seen before, that the data and the clock lines going to this left one might be damaged. But for that, I might need to look into board view of this board. And I will have a look again if there's a damaged trace. There might be a missing voltage then, or something similar to that. That maybe a trace goes close to these two sockets and then splits to these two sockets, or something like that, that I am missing, or knocked off component like that. So I will be having a look around the board and I will get you back as soon as I find something. So after quite some time, I think I finally found something. So when we're inputting the CPU and using our DDR tester, there is a line called VREF-CA. Let's go under the microscope and let me show you that. It's this one right there. This is a probe point that is normal for DDR4. And if we take our multimeter now, as you can see it on the display, we're currently in resistance mode. We are in 2K resistance mode. And if I go onto here, we see about 530 ohms. And now we switch to the side where we have no recognition of our RAM. And now let's go onto there again. And we have almost 0 ohms. And then I thought to myself, okay, let's take the CPU out. So took the CPU out. As you can see, the CPU is out. And if we now probe the point again, we see high resistance. So with taking the CPU out, we get a higher resistance. And then I went into the board view and looked where that line goes. So in the board view now, we have this line, which is called D4VR VREF-CA, as you can see in the top here. That is responsible for the two closer DIMM slots to the socket where we have the problems. And it has a bunch of capacitors here. Then it has a 1k ohm resistor. We can't have a short through that. We have another 1k ohm resistor. And then we have a 2 ohm resistor. And on the other side of this 2 ohm resistor, there's one capacitor and there's the socket with a single pin at the very top. And let's now look at the socket again. And if we have a look at the socket now, we have a single pin that is bent to the side. as you can see in the top, which is this pin right there. So let's bend you back. And I bet that this one is ground. So we currently have continuity mode. We are connected to ground with our black probe. And you can hear this is ground. And this is our VREF. So this was touching this here. So let's see, when putting the CPU back in, if we still have a short on that VREF line. Now we have our VREF line, and let's see. And we don't have a short. Let's see at the resistance. We expect about like 500 to 600 ohms, somewhere about there. And we see 530. So let's see if that has fixed our problem or not. And I got to be honest, I'm not too sure how I missed that that pin before, because we did take a look at the socket, and I guess I wasn't thorough enough when looking at it. So let's try now. So let's look at the passive power consumption. We have 140, 130, just normal. And let's see now, turning on. Let's get a heatsink onto here. Turning on and off. And now we have DRAM LED. And let's see. And finally, with this slot, we go to VGA. Oh, thank you. Now it's working. Now we go to the VGA LED. And now what I can also do, let's now get the post screen connected to here. And let's put all 4 DIMMs, just to show that all are now working. Let's now, with all sticks occupied, let's turn it on. Let's get a post screen into here. And let's see now. And we have VGA LED. And now we have the boot, and there's our boot screen right there. Very, very nice. Let's see. For the RAM capacity, and we see 20 gigs of RAM. All of them are recognized. And I will be going into Windows now. I will be checking out if this board works like it should. And get you back into here then. So I've noticed something else on this board, which is quite concerning. I noticed something else which is a little bit concerning. We have a USB controller here that heats up a lot. This is currently at 65 degrees. This is a USB controller right there. It might be the Ethernet controller, but I think it's the USB controller. And it's currently at almost 70 degrees. I will need to have a closer look at that. Plug in some more USB devices, because that might be faulty, to be honest, because that is very hot. But I will have to see for which of the ports this is responsible for. And yeah. So let's have a look together in the board view then. The post screen is still running, but let that run. It's this is media controller right here. USB controller. Let's see for which of these it is responsible, which would be going into this side. And this is the USB Type-C. It says Type-C, interesting. So the question is this also responsible for others, or is this all just Type-C stuff? Because this thing might actually be just USB-C stuff and only responsible for that thing. So I would guess that the USB-C isn't working on this thing, but everything, all of the other USB should be working, but we can test that. So we are currently in Windows. So we will be using this. This is a USB amp meter. And on the other side, we're going to be using a USB-C to USB-C. And this adapts USB-C to USB-A female. this adapter right here. So we can plug it in and let's see what we get on the USB-C. So let me put it into the USB-C right here. And we do actually get 5 volts. It's kind of hard to see, but top left corner says 5 volts. And the controller is still warm. Interesting. I'm kind of tempted to charge something through this and see if that controller blows up or not, to be honest. Let's get my phone and let's see if we can charge my phone via this USB-C port. So let's see, 1.1 amps, 0.45 amps. It does charge my phone. Question now is, let's see if you can see this. Bottom left says 0.45 amps, 4.9 volts. Let's see, is this controller getting even hotter? It feels like it's getting even hotter now. So let's get something else that I can, because I need my phone for using the thermal camera. So I've gotten something else to charge. This is a small lamp that I have, a headlamp that uses USB-C to charge. And we can plug the USB-A into here. And we now have almost an amp of charging. And let's see how hot that controller gets. Well, it stayed pretty close to its original temp. Even while charging, it is 70 degrees. And we are charging with almost an amp of current. If you can see here, bottom left says 0.28 amps, 4.8 volts. So a little bit of a voltage drop, but it does work. It does charge the lamp. Interesting. So maybe that just is how that thing works. I don't really trust that because that is kind of hot. But it does work. Let's see if data connection works. If the computer spits anything out if I connect my phone to it, that we have data connection. Let's see now if my phone now gets recognized. And now my phone also gets recognized. Now the OnePlus 7 is also shown. So, interestingly enough, that controller gets really, really hot, but it seems like that it still works. That is very odd to me, but it does what it's supposed to do. So, quick little investigation also about the USB-C there, just to be sure that it works. Was happy that I was able to show you something new with that, with the amp meter. But yeah, we got this board fixed now. I thought I might be doing 2 different things in this Joblot, but it turned out this one took a very long time for me to figure out what was wrong with it. Especially because all of the red herrings that were the backside of the board with all of the damaged traces. But yeah, with this cheap Chinese DDR tester, we got another board fixed. These things are really valuable. Like, they work pretty well. They are so simplistic. Like, at the beginning you really don't know what to do with these, but as soon as you get them to know a little bit, you can really start picking up on them. And yeah, they can really help. Only because of this pro point of VREF, I got to the point of measuring and then looking at the socket again and seeing this one pin that that was touching a ground pin. Because there's also SCL and SDL that you can probe here. And SPD on the other side, there's also 3 more probe points, and I was probing. And only with that, I was actually able to fix this board. And I've learned something new. I've never had this before, but I'm very happy that I was able to fix this board. Thank you very much for watching. Hope you learned something. All of my tools are linked in the video description. Hope to see you in the next one. This was Multimeter. Thank you very much, and goodbye.